Hello and welcome back to Math Class in Session. Today we're going to look at how to do word problems that involve headings and bearings. Headings are usually and bearings are usually 3 digits and always measured from the north in a clockwise direction. For example, a heading of 120. Start measuring from north and count 120 degrees around to the right, like a clock would move. So we can count here 90 degrees, 180 degrees would be too much. So 120 degrees must be in there. So we can draw a terminal arm in there and call this 120 degrees. And we would know that this must be 30 degrees because if this is 90 and this is 120, the difference is 30 degrees. So to be able to do the word problems, you have to be familiar with this concept. A 3-digit number that indicates a direction, 120 degrees, measured to the right from north. Let's do one more example to get used to this. How about a heading of 220 or 220? Start from north and count 220 degrees around the clock to the right. So it would be 90, 180, 270. Whoops, that's too much. It's only supposed to be 220. So it must be along here somewhere. In fact, it's right along there somewhere. So we would draw it there and call it 220 degrees. And we would know from that being 220 and this being 180 that this gap must be 40 degrees. So this single number tells us a lot about the direction and some angles on a diagram. We have to be familiar with that in order to answer the word problems. In fact, to make the diagrams on the word problems. Okay, here's the problem we'll do. A sailor out in a lake sees 2 lighthouses 11 kilometers apart along the shore. Now he would know they're 11 kilometers apart because he would have charts about these lighthouses. He gets bearings of 285 degrees from his present position for lighthouse A and 237 degrees for lighthouse B. From lighthouse B, lighthouse A has a bearing of 45 degrees. How far is the sailor from each lighthouse and how far is the sailor from the shore? Now, it's an easy problem to do if you can draw the diagram. So drawing the diagram is the challenge. So let's start off slowly. First of all, you'd be given a large white space and you wouldn't know where to start your diagram. That's why you'd be given a very large white space. And you'd probably put S down in the middle of it somewhere and build a diagram. So I'm going to call S where the sailor is. So S is my sailor. And I put him right here because I've got this paragraph to contend with and I know how the diagram turns out. Okay, now let's build a diagram around the sailor on the lake. S is the sailor. Bearings of 285 degrees from his present position for lighthouse A. So what we do is every time we put a point on one of these diagrams, we build this thing. It's called a compass rose. A little vertical line, a little horizontal line. And we start measuring 285 degrees like we did before. So it will be 90, 180, 270, and 15 more makes 285. So along here somewhere is lighthouse A. And we know that this is 15 degrees. Okay, so we've handled the 285 degrees. And it's 237 degrees for lighthouse B. So from the sailor, we have to count 237 degrees to get to lighthouse B. So let's start counting. 90, 180, and now we have to go from 180 a bit further to get to 237. Now if we went to here, it would be 270, and that would be too much. So it's in here somewhere. So it's along here, along this line, somewhere is lighthouse B. The question is, where? Well, the hint is given here. From lighthouse B to get to A, you have to go on a bearing of 45. So to get to A, we would have to go up and to the right a bit. So B must be well down here. Now this would take, you would do your diagrams in pencil and you would try it and it might not work out the first try and you would erase it and fix it. Now, let's just add to our diagram. That's 237 degrees. It says for lighthouse, 237 degrees for lighthouse B. There's our measurement of 237 degrees. There's our lighthouse B. Now there's a gap here. Let's count 90, 180, 270. There's a gap there. We can figure out what that gap is. It's 33 degrees because 270 take away 237 is 33 degrees. And so this angle will be 48 degrees if we ever need it. And we will. Now we can draw the shoreline. And we can put the 11 kilometers between A and B. So it says the two lighthouses are 11 kilometers apart. I have them 11 kilometers apart now. Let's go to B and draw a compass rose, a vertical and a horizontal line. And we know that it says from lighthouse B, lighthouse A has a bearing of 45 degrees. So from B to go along this line must be 45 there. And because this is a compass rose, this is a horizontal line, and this is a horizontal line, which means it's parallel to this other horizontal line. And so we have this Z. Look at the Z. That's a Z. And so if there's 33 in this part of the Z, then there's 33 in this part of the Z. And take a look at this. This is 90 degrees here. From north to east is 90 degrees. And so there's a gap here that we can figure out because it's altogether 90. So 45 and 33 together make 78. So this must be 12 to make 90. And in triangle BAS, we know this is 48. It's 15 plus 33. So this is 48, and this is 12, which makes 48 plus 12 is 60. So this must be the remainder to make 180. And what, take 180, take away 60, that leaves 120. And you can check by going 120 plus 48 plus 12. Yep, that's 180. So look at this, our diagram. We want the distance from the sailor to the lighthouses. We'll call that one X, and we'll call the other one Y. Now it's a very simple sine law application. Just do a sine law and get X and Y. The whole challenge was drawing that diagram, and it takes some practice. And by the way, I will provide a sheet with some practice questions. Now let's do it. It'll be X over sine 120 equals 11 over sine 48, and it will be Y over sine 12 equals X over sine 120. Let's do those. Y over sine 12, Y over sine 12 equals 11 over sine of this entire angle, 48. Multiply by 11 times sine 12 over 48 on a calculator, and it's 3.1 kilometers to lighthouse A. Do it again, so X over sine 120 equals 11 over sine 48. 11 times sine 120 over sine 48 on a calculator, and we've answered the questions. And there was one other question: how far is the sailor from the shoreline? Well, there's the shoreline, here's the sailor. Let's draw straight over. Now that forms a right angle triangle, and we want that distance, D, call it D, I suppose, Now notice this is 120, so this must be the supplement of 120, and that's 60, because 120 plus 60 makes this 180 degrees. And now we'll do SOHCAHTOA in this triangle. Sine 60 equals opposite over hypotenuse, so sine 60 equals d over y. But y we figured out in the last diagram to be 3.1, so d is actually 3.1 sine 60. And we've got the distance to the shore. It's 2.7 kilometers. Now this comes with practice. One has to try to learn to make these diagrams, and your first attempts might not look too great. But with practice, it gets better and better. So you have to just try to do the worksheet that will be coming soon. Have a good day and enjoy your math. It can be fun.